Okay, so before we talk about access tokens, we have to do a quick refresher of the access control model on Windows. Now, red teamers have made entire careers out of the rabbit hole that this is, and obviously in our quick little tutorial here, we're not going to be able to cover everything. I'm going to simplify a lot of concepts as I go through here, but hopefully by the end you'll have a general concept of how this sort of stuff works under the hood. But more importantly, when you see it in code, you'll understand the references and you'll understand what's actually happening under the hood when these specific APIs are called. Okay, so access control model, there are three main components. There's the access token, which we're going to dive deeper into in just a minute. Now, the formal definition of the access token is a volatile repository for security settings associated with the Logon session. Blah, 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 blah. Now, that's kind of a mouthful. For now, what we're going to think of this as is just a piece of data that stores the user and group SIDs associated with the user who spawned the process, and also a set of privileges that can be enabled or disabled for that process. That's just the general concept of an access token. We're just going to put that aside for right now. The second part of the access control model is the securable object. Pretty much everything in Windows is a securable object. I mean, basically process, file, registry key, token, everything is a securable object. So really it's just any object in Windows, and the securable part is the discretionary access control list, or DACL, as you've probably heard it called before. What this is a list of user and group SIDs that can access the object and what their access is. So it's basically an access control list for the object. So you got your access token, your securable object, and the third part is the intention of the process or the command. And by this, we just mean, what do you want to do when you access the object? Do you want to read it, write it, query, create a new process, etc.? These are all intentions or intents that you can have when you access an object. So you can see at this high level, it's pretty straightforward. You basically just have who I am and what my permissions are. You have the object I want to access and what's being allowed to access it and how those things are being allowed to access it. And then you have the action that you want to take on the object, right? So you got your three main components here. Now you might say, well, that's all well and good, but how does it actually work in practice? So what I want to do is I want to walk you through a simple example here where you have two processes, process A and process B. Both of them have a DACL and both of them have an access token, right? So any process is going to have discretionary access list, and it's also going to have an access token. I'm going to talk more about the access token and how it gets the access token in just a minute, but for right now, just know that every process has an access token. Okay, so let's say process A wants to query the name of process B, right? So we have this nice API here, query full process image name. That means given a process PID, tell me the name of the executable on disk that spawned that process, right? So that's the action we want to take. Before we can take that action, we need to open a handle to the process. And this is where you ask for permission and you state your intention. So in this case, we have process query limited information. So that's the permission that we would like to access process B with. So let's walk through the steps, step by step, how the access model works. So first up, we have the token of process A, and that tells you who spawned process A, what groups they belong to, and the special privileges associated with the token. Then you have the discretionary access list of process B, which tells you who can access the process and what access they have. Then we have the intent. So you want to access it with query limited information. So given those three components, the access model first checks the SIDs of the access token of process A against the DACL in process B. There's a SID foobar in process A, and it checks on the access list of process B, what is this SID allowed to do? And process B tells us, well, we have process full access for that SID. Once they know what the permissions are for that SID, they check the intent against the allowed access. In this case, it checks out. You have process full access, so query limited information is no problem, and this is allowed to go through, right? So this is just a simple example where they're just relying on the SIDs for access. They're not accessing any special privileges yet, but it's illustrative of the simple under the hood process that's happening every time you try and open a handle to a process and you state the intent that you want or the access that you want for that handle. Now let's take a look at a special privilege, which we just saw in the malware that we reversed, What about if the process A has SEDebug privileges? How does that work? Well, SEDebug privileges are a special privilege that your access token can have, which is basically like God mode on the system.
Groovy.
And in practice, this allows you to skip the DACL check on a process. So if you have SEDebug privileges, it's kind of like a shortcut where you don't actually need to check the DACL. Now under the hood, it's a little bit more complex than that, but without getting into a couple hours long explainer about how all that works, the best model to have in your mind is just that if you have SEDebug privileges, you basically have process all access to any process on the host, with the exception of a few special cases, which we're not going to get into, like PPL and stuff like that. So we're not going to get into that. But for the most part, if you have SEDebug, you have process all access to the other processes on the host. So how would that look here? We check the access token, you have SEDebug privilege enabled, then there we go. You can access process B, no problem. There's no DACL check. So that's kind of the model of what you want to keep in mind when you see SEDebug privilege. If you see that in malware, that's a very powerful privilege, and it's definitely going to be doing something weird between a bunch of processes. Okay, so let's dive into the access token a little bit deeper. I want to give you a brief overview of how this works because it's important if you're doing any sort of live or dynamic analysis of processes. This can trip you up if you don't understand how it works under the hood. So here's Microsoft's very complex diagram of how the local security authority works. I'm going to go with this clean diagram that I stole from an Elastic post. I'll link the blog post below. I encourage you to read it. It's very good. And it's basically just going to go over what I talk about here today. So you have something called the local security authority, and that's the mechanism that checks your password and your username when you log in. And for this tutorial, I'm just going to black box that. Okay, so you just have to think of that as a mechanism that's checking your username and password. That is very complex. How the LSA works is, again, a couple hours long tutorial. I don't even know half of how it works. I only know the basics, and I certainly don't want to relay bad information to you. So for the purpose of this, it's a black box that just does the authentication. So when you go to sign in, you send your username and password to the LSA, and it spits out a session with a logon session and an access token. So the way this works is Microsoft has some confusing names for things. You basically have a session, which you can think of sort of like a terminal session, and this is what's going to encompass your entire access on the host. So that's your session. You also have a logon session, and a logon session is basically the way to identify you on the host. So it has information like your SID, how you logged on, what type of logon it is, interactive, network, etc., right? You also have an access token, which is generated by the LSA, and the access token references the logon session. So they're two separate things. There's the logon session, which tells the host who's accessing it, how they're accessing it, and who they are. And you have the access token assigned to the user, which has a list of SIDs, group SIDs, the user SID, special permissions, that sort of stuff. And it also has a reference to the logon session. So every access token has a reference to the logon session that was generated along with it. Okay, so let's complicate this a little bit more and assume that our user is an administrator. How does this work? Well, ever since UAC was introduced, Microsoft has had to work around the fact that the same user can run both a standard and an elevated session. And the way they do this is they use something called a split token, and that's kind of a misnomer because really what you have are two different access tokens completely. But they call it a split token, and the way it works is the standard access token actually links to the elevated access token. So if you're operating in a standard session and you want to run a command elevated, so you call into UAC to authenticate, the authentication process will check your standard access token, and from there it can link to the elevated access token. And the spawn process will actually have a copy of the elevated token, not the standard access token. We're going to talk in a minute about how the tokens are propagated to processes that you spawn, but for now, just know that the elevated tokens are copied into any elevated process that you spawn, and the standard token is propagated into any standard processes that you spawn. So one extra gotcha before we move on from this, Microsoft calls this a split token, and in the documentation you'll find references to the fact that both the elevated and the standard access token link back to the same logon session. In practice, this actually isn't really the case. In practice, when a user who has administrative privileges logs on through the LSA, they're actually given two identical logon sessions. The sessions are identical in all ways, except the session ID is different. So you're going to have two different session IDs for the same user, and each one is going to have one token associated with it. One will have the standard token and one will have the elevated token. So I'm going to show you guys that in a minute. And the only confusing part is if you're reading documentation, often you'll hear things referred to as split tokens assigned to the login session, as if the login session is singular. But in practice, it is actually two separate logon sessions with two separate logon IDs. Just a bit of confusion there. It could throw you for a loop. So let's talk about how the access tokens are used when the user spawns a process. So of course, these access tokens that are generated by the LSA are assigned to the user themselves, right? But of course, the user is going to be spawning processes. And as I mentioned, for each process that's spawned, the access token of the user is copied into the process. This is the mechanic that allows you to query an access token for a process and not just for a user. So inside of each process is an access token which references the logon session of the user who spawned the process. So in this case, if the user launches explorer.exe, which is the standard shell which is usually launched when you log in, the access token of the user is then copied into explorer.exe. Now, if the user launches an elevated command, so for example, let's say they right-click on cmd.exe and launch as administrator, then UAC will kick in, they'll authenticate the user, and they will copy the elevated access token into that elevated process. And of course, that token will reference back to the logon session that was associated with it during the initial logon. So up to now, we've done a brief overview of the access control model under Windows, the three components that are required, so the access token, the DACL, and the intention of the action that you're trying to take. We've also covered how access tokens are generated and how they're linked to logon session and propagated to processes that are spawned by the user. There's just one last thing that we need to cover off, and that is how these special permissions like SEDebug privilege are actually used in the token. So there's a difference between having that permission and having the permission enabled. So let's take a look at our example here and assume that this user does have SEDebug privileges. So when they spawn cmd.exe as an elevated process and their elevated access token was copied into the process, it would have the privilege SEDebug privilege, but that privilege would be disabled, which means it can't be used in the process yet. If they want to use it, they need to actually enable that privilege. That's where you would see an API call like AdjustTokenPrivileges. If they adjust the token's SEDebug privilege and enable it, then they can go ahead and use that during the intent for any actions that they're taking on an object. So once the API is called, they've adjusted the privilege, then it'll show up as enabled, and any open process calls that are made after the token is adjusted will have the SEDebug privilege enabled, so they'll skip the DACL check. So as you're reverse engineering malware, and also if you're looking at API traces from sandboxes, just keep that in mind that it's not enough to actually have the SEDebug privilege. The process needs to be spawned as elevated and bypass UAC somehow, and they have to enable the SEDebug privilege before it can be used. So those are the two hurdles that malware developers need to jump over in order to get this God mode style access on the host. Now I want to wrap up here with a quick demo, but before I do the demo, I just want to mention once more that what I've presented here is a high-level view of how this stuff works. In fact, under the hood, it is extremely complex. There are many situations that can be taken advantage of. I haven't talked about token impersonation for threads, or how that can be abused, or how you can use the DACL to strip privileges from a process that you spawn, preventing privileged access. It's an endless rabbit hole. Like I said, there are people who have made their entire career out of finding little nuances in this system that they can exploit. So we've just touched the surface here, but the point of this was just to give you a quick overview so that when you see this in code, you can keep in your mind what's actually happening under the hood. And also, I've linked below many different excellent resources that you guys can go and dig in deeper if you want to learn how this stuff works. So I've linked that below. I encourage you to go check that out. Now let's hop over to our VM here and we'll do a quick little demo and I'll show you how all this works. So I'm going to use the sysinternals tool LogonSessions to list all the logon sessions. I'm going to show you those 2 sessions that were created when my user admin was logged into the host. So I'm going to also do a -P to list all the processes associated with each session. Make this a bit bigger so you guys can see. Okay, there we go. So if we look at our sessions here, you can see this is my username, admin, on my VM RELab 10. You can see I have an interactive logon. My session is 1. So remember I said there's a session, sort of like a terminal session, which groups all of your activity together. This is my user SID right here, my logon time. This is a logon server. And you can see here are all the processes that are running under this logon session. Now I want to show you, if I scroll up just a little bit more, look at that. There's another logon session under my same username. It's interactive, session 1, my SID. Everything looks pretty much exactly the same. And you'll notice there's a lot fewer processes running under here, only cmd.exe and logonsessions.exe, which is of course this administrative command prompt that I'm running right here. So that's the 2 logon sessions that are created because I'm an administrator. This one is obviously the elevated one, and this is the one that is associated with my standard token. Now I'm just going to minimize this, and I want to take this one step further and use this nice tool called Token Viewer. And you can see here, make it bigger so you can see. And I'm also going to sort by name here so it's easier to find these things. So you can see here there are 2 command processes spawned by my user here. The first one here is medium integrity and the second one here is high integrity. So this is the 2 command shells that I have open here, just the regular one, standard one here, and the elevated one that I just used to run the logon process command. So if we right click on, let's say the elevated one here, and we open our token, you can now see the token for that process. You can see the user, token ID, and the authentication ID. It's a little bit misleading here, but that is the ID of the logon process associated with this token. So if we go back to our logon processes here, I'll line them up side by side so it's easier to see. There we go. So our standard session here, so the one with all the processes in it, is 538C1. So let's take a look at the non-elevated command. I'll open that token. So that is 538C1, right? So the authentication ID matches the logon session. And for my elevated logon session, or the one that I thought was elevated because it has less processes and has the command.exe here. So this one is 53, and if we come over here, this is the elevated process, right? So this is the high integrity level cmd.exe, and you can see here we have 53897, right? So the authentication ID matches back to the logon session. Now it's kind of fun to explore with the token viewer to see what tokens are associated with what process. Just kind of an interesting thing to explore on your own host, see what's going on. What I'd like to do though is I have a quick example here, a small piece of code that I wrote to demonstrate turning on a privilege that exists in a token. So here you can see we have enable shutdown privilege. Shutdown privilege is, as you might imagine, the privilege that allows you to shut down the host. So my token is going to have that privilege, but it's just not enabled by default. And so what I'm going to do is I'm going to use the same code that we saw in our malware here. I'm going to open a handle to our current process with privileges of token adjust and token query. Then I'm going to look up the privilege LUID for SE shutdown name, and I'm going to then enable that privilege, and I'm going to adjust the privileges of my current token, right? Now what I've done is I've set this up with some git chars here to actually halt the process before the privilege is changed. So what I can do is I can run this. I'll attach to the process with the token viewer. I'll show you the privilege of SE shutdown is disabled, and then I'll enable it with our code here, and then I'll show you that it's enabled in the token viewer, just as a demonstration of how these things are changed in code and how those changes are represented in the host. So let's just run this here from the command line. All right, so it hasn't enabled SE shutdown privilege yet. I have to press enter to do that. So let's take advantage of this. We'll go back to our token viewer here. Just close these up. If you hit apply filter, it refreshes the process list, so that's just kind of helpful. And then let's look for our program here, which is named Token Spy. There we go, Token Spy. Let's open our token here. We'll go to the privileges, and you can see that SE shutdown privilege is disabled. So I don't have too many privileges in the standard token, but the ones that I do have, most of them are disabled. So let's just close this up. And now I press enter to enable it. All right, so it should be enabled. Let's come back here, take a look at the token, take a look at the privileges, and you can see now it's enabled. So that's just a simple example of enabling a simple privilege in an access token and how the changes are reflected on the host. So hopefully this is a good overview for you guys. And now when you see token privileges being adjusted in code, you'll understand how that impacts the system. So again, I encourage you to try some of this stuff out on your own host. And if you're interested in this kind of stuff, definitely read through the linked material I have below on access tokens. Again, I've just barely touched the surface in this tutorial. All right, with that, I'll see you in the next tutorial. Bye for now.